Welcome to another installment of Data Science Simplified. I am Dr. Mechi Kenwa, and I am the Chief Data Strategist of Data Products. Today, we're going to talk about understanding data. No, not that data. Although I never did understand why a sophisticated android couldn't use contractions, or why he's so fascinated by dreams, love, and well, that's for another episode. For today, we'll explore different ways that you can analyze data as in the characteristics of information that one collects. For the sake of today's discussion, we'll focus on numerical data. They say that numbers don't lie, and while that's true, numerical data sets can be interpreted in a number of ways. Today, we'll see how analysts can begin with a large data set and interpret it to tell a very rich and complex story. Before you do anything, it's important to first describe our data. Here, for example, is a data set of grocery purchases. A good description should answer the question, what happened, by summarizing the data. This is usually done in the form of a dashboard. In this case, here is a simple data set that represents each customer with a unique 4-digit ID. Next, we see the date they went shopping, and finally, the description of what they purchased. This simple descriptive analysis is what business applications, for example, use to describe KPI or key performance indicator dashboards, or use to drum up their monthly revenue reports. Now, let's leapfrog to a slightly more advanced way of interpreting data, predictive analysis. Returning to our grocery shopping example, we can begin by sorting through the dataset using any number of variables, including the customer ID. Let's say that you wanted to learn more about shopping habits of a customer number 2300. Let's call him Steve. We can begin by filtering out all transactions specific to that customer ID. From there, it helps to organize the transactions chronologically in order to build a historical picture of Steve's shopping habits. After doing this preliminary work, one ends up with a chronological record of everything that Steve has purchased at the grocery stores for the past 5 years. Now, a pretty basic analysis would be to look at the frequency with which Steve purchases different items. We see that over a span of 5 years, he's bought pork 180 times, white wine 60 times, and oranges 200 times. While it might be safe to say that Steve is apparently a carnivore with plenty of vitamin C in his diet, is it enough to predict his shopping habits in the future? Perhaps we could say with reasonable certainty that Steve will most likely buy oranges at some point in the future. But when? Well, let's break it down a bit further to sort the purchases by season. It turns out that 60% of Steve's orange purchases occurred during the winter months, December through February, with most purchases done on the during the weekday. We can begin to make a reasonable prediction about what Steve's likely to purchase in the future and when. Predictive analysis is usually far much more complex, however, involving massive data sets and complex analysis. Finally, let's talk about causal analysis. This is a type of analysis you could attempt in order to find out what happens to one variable when you change another. These analyses usually require randomized studies. Imagine that you have data on the number of daily visitors to your website where you sell knitted sweaters for ferrets of all sizes and shapes. Perhaps you're interested in learning what changes to the site can result in different visitor behavior. You might try changing the featured image on your homepage to a more photogenic ferret, or perhaps alternating the color of the featured sweaters. If you were able to show that displaying images of ferrets wearing red knitted sweaters consistently resulted in more visitors that signed up for your newsletter and or purchased more sweaters, then you could successfully say that you have performed causal analysis. And there you have it. We've covered three common types of analysis today that are all great ways of understanding data: descriptive analysis, predictive analysis, and causal analysis. There are other types of causal analysis, of course. For example, we have exploratory, inferential, and mechanistic. Everything depends on the type of data that you have available, what sort of problems you're trying to solve, and what insights you're striving for. Thanks for joining us today, and don't forget to click like and the red subscribe button below to get notifications for future episodes of Data Science Simplified. You can also check out our social media pages on Facebook, Twitter, and LinkedIn. See you next time. Bye-bye.